Hello, and welcome to the next installment of our at-home AP Psychology videos. So without further ado, let's go ahead and get to our module for today. This is module number 40, and we are talking about studying genetic and environmental influences on intelligence. So we just have this module and then one more to go to cover our intelligence portion of this unit. All right, so it's honestly pretty short and sweet today. We're talking about heritability and then basically genetic versus environmental influences on intelligence. We're actually going to look at this question in class, so I'm going to skip that for now. All right, so starting off, one thing for us to consider is, what do you think? Is intelligence something that is a result of nature, meaning our genetics, or nurture, meaning the environment and maybe like how you are raised, what kinds of resources you have? So something we have seen is that the most genetically similar people, meaning nature, have the most similar intelligence scores. So first, let's stop real quick and recap a couple of things with correlation. Remember, a correlation of 1.0, or either if that's positive or negative, that means a totally perfect correlation. So the two variables completely go together. Whereas a correlation of 0 means there's absolutely no relationship between the variables. So keep that in mind as we take a closer look at this graph down here. And don't forget that nature or nurture is still one of the biggest debates in psychology in all its different areas. So we don't necessarily have one perfect great answer to this. So you can think about it a bit on your own. We're going to take a look at that video in class. So let me go to our next slide here. So what does the research show regarding the genetics of intelligence? We have seen that the intelligence test scores of identical twins raised together, and don't forget, identical twins means they share exactly the same DNA as each other. So when they're raised in the same environment together, they are nearly as similar as those of the same person taking the same test twice. So identical twins raised in the same environment is as if it was the same person, just taking the test more than once. Identical twins also exhibit substantial similarity in specific talents, so things like music, math, sports, and heredity accounts for more than half of the variation in the national math and science exam scores of British 16-year-olds. So what's the deal? Are there specific genes that are known for this genius that people might have? So we can see that 200 researchers pulled together all the data they had on over 100,000 different people, and all of the gene variations analyzed accounted for only about 2% of the differences in educational achievement, meaning that it's not like there was just one specific gene they found of like, that's it, that's the intelligence gene. But instead, there's so many different gene combinations that come together that kind of compound for this idea of intelligence. And we'll come back to this idea a little bit later in this module. Another British study that was a follow-up to that recently found that genes predicted 9% of the variation in school achievement at age 16. Okay, so what does the research show regarding the environmental factors of intelligence? We just looked at the gene side. What about the environment? So in one Swedish study that was really, really large, children adopted into wealthier families with more educated parents had IQ scores averaging 4.4 points higher than their non-adopted biological siblings. So the ones who were in families that had more money and better education tended to score higher than other siblings who were not adopted. So again, the influence of environment over genes. Adoption enhances the intelligence scores of mistreated or neglected children, which is good. So that means if there is unfortunately lower intelligence you might see in certain children who were neglected, there is still hope of we can hopefully try to make up for some of that neglect and abuse that was there, and therefore try to help get them a little more back on track in terms of developmentally being at the same level as other children their age. Also, where environments vary widely, as they do among children of less educated parents, environmental differences are more predictive of intelligence scores. So through all this, we can see, all right, we know genes are pretty important with intelligence. And also it seems like environment is pretty important with intelligence as well. So let's take a closer look at this graph that we had on a couple slides back here. So this is where we're thinking about correlation and how it ties together. So if you look at this first bar here, we're looking at identical twins who are raised together in the same environment. So their genes are the same and their environment are the same. And we can see that that is a correlation of about 0.85, which is very, very high. So that's a pretty high correlation for identical twins raised together. Then we have identical twins raised apart. So same genes, but different environment. And we can see it's still a pretty high correlation, about like 0.72, maybe somewhere around there. So still pretty highly correlated because they have the same genes. However, not as highly correlated as the individuals with the same genes and the same environment. Then we can see fraternal twins who share about 50% of their genes and their DNA. Fraternal twins who are raised together, so it's another step down in terms of correlation there. And then siblings who are raised together, again, another step down in terms of correlation. And then finally looking at unrelated individuals, so ones who don't share any kinds of genes, they're just like you and a random friend. Unrelated individuals who are raised together, they definitely have the lowest correlation of intelligence scores. So we can see that both genes and environment definitely have the biggest impact on correlations between intelligence scores. And again, just maybe look through that a little bit more on your own, spend more time if you feel like you need to, because it is really important on AP exams. You will see some things like that with graphs, and you have to be able to pull apart like what exactly is this telling me here? What does this mean? So let's look at our first question here. There is a greater correlation between the IQ scores of identical twins raised together than for fraternal twins raised together, as we just saw in that graph. So what conclusion can be drawn from this data? Go ahead and take a second to think about it. Pause if you need to. But our correct answer here is letter D, that there is a genetic effect on intelligence, because we know that the ones who have the same genes had a better correlation of intelligence than the ones who did not have the same genes. We're almost exactly the same. So what exactly determines intelligence? Is it genes or is it environment? Again, we don't really have a good answer there. So seeking to try to disentangle genes and environment, to try to break them apart, researchers have compared the intelligence test scores of adopted children with those of their biological parents, so the ones whose genes they share, and their adoptive parents, meaning they don't share any genes, but they live in the same environment with them. So over time, you can see that adopted children accumulate experience in their differing adoptive families. So what do you think? Do you expect the family environment effect to grow with age and the genetic legacy effect to shrink? Here's what we've seen with research. As the years went by in their adoptive families, children's verbal ability scores became more like their biological, meaning nature, parents' scores. So you can see over time here, if you look at these bar graphs right here as well, that the intelligence level depended more on the child's biological parents more so than their adoptive parents. So again, that's kind of another piece of evidence more towards the genetic side, but there's definitely still an environmental side for sure. Sorry, 1 second, my slides are getting frozen here. There we go. So do genetic influences become more apparent as we accumulate a life experience? Identical twins similarities continue or increase into their 80s. Adopted children's intelligence scores resemble those of their biological parents much more than their adoptive parents. And the heritability of general intelligence increases from about 30% in early childhood to well over 50% in adulthood. So we need to pause and refresh our memories here on something. This word heritability, super, super important here. So maybe take a second to think back yourself and try to remember what this might mean. We talked about it in Unit 2 when we were talking about the biological basis of behavior. So heritability is very important in understanding intelligence and other traits. Maybe think for a second, what do you think that means? Pause if you need to. Let's see here. Heritability is the proportion of variation among individuals in a group that we can attribute to genes. So how much can we attribute the differences between people on specific traits? How much of that can we attribute to their genes rather than environment? So the heritability of a trait may vary depending on the range of populations and environments studied. So I do want to point out too that heritability is not the same thing as heredity. Heredity or hereditary being more of like passed on in your genes kind of thing. Heritability kind of pulls from that idea. However, it's not necessarily saying how much are your own traits influenced because of your genes, as we're going to see in 1 second here on this slide. So what does this phrase intelligence is about 50% heritable? What does that mean and what does it not mean? It does mean that genetic influence explains about 50% of the observed variation among people. So when we look at all people together and we can see how their intelligence varies among each person, about 50% of that variation is because of genes, because of the influence that genes have on intelligence. It does not mean that your intelligence is 50% genetic. So look at this really important note I added down here, that heritability looks at differences within a group, not within an individual. So it's not that 50% of my intelligence is because of genes. Instead, it's the difference amongst all these people. About 50% of that difference is because of genes. All right, so it is difficult to kind of understand exactly the difference there. So maybe spend more time looking at that if you need to. But heritability is a very, very important term to make sure you understand in psychology for sure. All right, so now kind of looking at the environment side of things again here. So consider Mark Twain's fictional idea of raising boys in barrels to age 12, only feeding them through a hole. Obviously, totally not ethical. And again, it was just a fictional idea. They didn't do it. So if we were to follow that suggestion, the boys would all emerge with lower than normal intelligence scores at age 12. Why would that be? Well, probably because of the fact that they're not getting the kind of nurturing from the environment that they need to be able to develop at a typical pace. That means that they'll have lower intelligence scores. But the thing is, given their equal environments, they're all raised in the exact same barrels, all getting the same food. So given the fact that they have equal environments, their test score differences could be explained only by their heredity. So why is that? That is because of the fact that, like we said, we know the environment is exactly the same between them. So it's got to be that the differences between them are because of their genes, the differences between them and other people and everything. So again, another example of how it's really hard to just say like it's 100% environment or 100% genetics that is responsible for intelligence. It's one of those things where it's both nature and nurture for sure. So second question here, heritability relates to the what? Again, you might need to pause to read through these different answer choices here. This is letter D, the extent to which variability among individuals' intelligence scores can be attributed to genetic variation. Definitely pretty wordy and lengthy, but make sure you take some time to look through each of these options here and how letter D is in fact referring to heritability. All right, let's look at this third question here. This one is not multiple choice. You do have to think a little more, and it is a little bit tricky here. So explain whether each of the following comparisons demonstrates the influence of genetics or of environment on intelligence. So in the first case, we're looking at the correlation of intelligence test scores for identical twins raised together is about positive 0.85. For identical twins raised apart, the correlation is about positive 0.72. So what is that one telling us that intelligence is more based on? Is that looking more at the genetics or at the environment? So again, it's a bit tricky. You have to think through it. But this first one is talking about the influence of the environment. And the reason for that is because we are looking at identical twins in both scenarios, meaning that their genetics are being held constant. There is no difference in their genetics since they're identical twins. But the thing that we are changing is their environment, either if they're raised in the same environment or apart from each other. So you can see the fact that there's a difference in their intelligence scores means that it's got to be attributed to the environment because we know their genes are the same. Looking at the second example here, the correlation of intelligence test scores for identical twins raised together is about positive 0.85, as we just saw. For fraternal twins raised together, it is about positive 0.60. What is this one looking at? The influence of environment or genetics on intelligence? So this second one is definitely looking more at the influence of genetics now on intelligence for exactly the opposite reason of the first one. Here, we are keeping their environments the same because these individuals are being raised together, so we know they have the same environmental influences. But the thing that is different between them is how much of their genes they have in common, because we're looking at identical twins who share just about all the same DNA versus fraternal twins who only share about 50% of their DNA, which is the same as them and any other sibling they might have that they weren't actually twins with. So this one is, we are only changing the genetics here, not the environment. So this one is telling us that genetics definitely has a part here. So yet again, another example of it is both environment and genetics, both nurture and nature that play a part in intelligence. So I kind of alluded to this earlier. Something we know about intelligence is that it is polygenetic, most likely. So that means that it is involving many genes. As I said before, it's not like there's just this one gene that we can see of like that is the intelligence gene, but instead it's a combination of all these different genes. And it's really hard for them to tease them apart and find exactly what they are. But polygenetic means that it's a combination of a bunch of genes together that make up for having intelligence. So if you relate that to like height to try to understand this a little better, looking at individual height differences, it's similar where what matters for intelligence is the combination of many different genes. It's again, not like you just have one gene for height or one gene for intelligence. All right, so looking at the bad side of environmental influences here, what is the impact of neglect? What can that do? So we have seen that some Romanian orphans, like this adorable little child here, I'm sorry, I cannot even pronounce this orphanage name here. In 1990, they had minimal interaction with caregivers and then unfortunately therefore suffered delayed development. So they were not on track developmentally with what other children their age should be. So what do we see about that kind of extreme deprivation in intelligence? What relationship is there? So this researcher, J. McVicker Hunt, observed that the typical child in a destitute Iranian orphanage he studied could not sit up unassisted at age 2 or walk at age 4. So again, not keeping up developmentally the way they should be. The little care that the infants received was not in response to their crying, cooing, or other behaviors when they're trying to tell someone they need something. So that means the children developed little sense of personal control over their environment. If I cry, no one's gonna come, so like I can't do anything about that. That's kind of what happened with them. So they were instead becoming passive, in his word, glum lumps. So what kind of training then, thankfully, did this researcher Hunt conduct after finding out that kind of research there? He then began to train Iranian caregivers, teaching them to play language fostering games with 11 infants. So the caregivers imitated the baby's babbling, engaged them in vocal follow the leader, and also taught the infant sound from the Persian language. So great news here, thank goodness. By about 22 months of age, infants could name more than 50 objects and body parts, and that means that they also charmed visitors more when they are coming to look for adoption. So an unprecedented success for the orphanage is that most of those children were in fact adopted. So that is thankfully a really great outcome of how we can see what research does and how we can use that in a training way to hopefully make a better difference there. All right, so how can early intervention impact intelligence? I've just got to say, I love this kid right here. Look how eager he is. Just be like, me, I got this. I know this answer. I love his enthusiasm. So in childhood, schooling is one intervention that pays intelligence score dividends, meaning that education does definitely make a huge difference. So schooling and intelligence interact, and then both later enhance income. We need to bring this point up again. This is very similar to when we were talking about grit and what grit has to do with intelligence. So psychologist Carol Dweck reports that believing intelligence is changeable, not fixed, it's something you can change, that fosters a growth mindset, a focus on learning and growing. Whereas the other mindset she kind of identified is a fixed mindset, which would support a set, unchangeable level of intelligence throughout life. So basically, and I'm sure you've kind of heard of these now because this is an area of positive psychology that is being very widely shared in schools and other kinds of educational environments, that we really need to focus on growth mindsets over fixed mindsets. So, growth mindsets, you believe you can change and make a difference in certain things. Your traits are not just 100% set in stone, versus a fixed mindset of, well, it is what it is. I can't do anything about it. So, like, might as well not even try. It's not up to me. That's kind of the difference there. So, Dweck teaches young teens that the brain is like a muscle, growing stronger with use as neuron connections grow. And that's something we learned again back in Unit 2 of how the more you're using certain neural firing, those synapses grow stronger and make better connections there. So, what does research show about a growth mindset? Receiving praise for effort and for tackling challenges rather than for being smart or accomplished helps teens understand the link between hard work and success. They also become more resilient when others are frustrating them, meaning they can kind of bounce back and overcome hardships. And superior achievements in fields from sports to science to music arise from the combination of ability, opportunity, and disciplined effort. So again, this is going back to that idea of grit that we talked about a couple modules ago, where one of the most detrimental things you can say to someone is, you are so smart. And it's weird. You might think like, oh, that's something I feel like that should be good. However, that is kind of taking the fixed mindset approach of like, you're lucky. You're just someone that has that smart gene. You are really, really smart. And that's just the way things are. So that means if you're not getting told that you're not smart and there's nothing you can do about it. But that's not true. That's not the way it is. So instead, we need to look at that growth mindset of, yeah, you're born with certain genes, but we know how much the environment has an impact on the way those things are expressed, and that you absolutely have the ability to work really hard at something and improve your success with things. So we know that being successful is not just about your natural traits and your natural level of intelligence. It's also about how much work, how much grit you put into things. So it's really important to take that growth mindset over fixed mindset. Sorry, I'm talking a lot about this, but it's a topic I'm really, really passionate about and I think is so important, especially for people your age. It's definitely something I'm not totally done growing in, but it is really important to keep this in mind as you are moving forward in life. All right, so our last question here. According to Carol Dweck, the lady I just talked a lot about, fixed versus growth mindset, students are often hampered by fixed mindset. So what does that mean that they believe? Take a second, look through your options. Fixed mindset would be letter A. Intelligence is biologically set and unchangeable. There's nothing you can do about it. And again, we know that's not true at all. You can, in fact, make a difference with some things, even though there is a genetic component to it. All right, so that is it. Awesome job. I hope that this was all making sense for you. If not, maybe go back and look at a couple of slides or replay the video a bit if you need to. And please come to class with questions so that we are ready to explore these topics a bit more. Thank you guys. Have an awesome day. We'll see you in class. Bye.